Hello, friends. Hello, people of God. Hello, Africa. Hello, Asia. Hello, America. Hello, North America. Hello, South America. Hello, United States. Hello, Canada. Hello, other continents that are China, Asia. Is it Asia? Asia? Yeah, I don't know how to put that. So, hello, all continents around the world. I welcome you once again to this specific lecture. And thank you so much for tuning in. And thank you so much for loving this channel and for supporting this channel in making videos like this. Today we are going to prepare invert syrup, and the person presenting to you is by the name shown below, and that is Miss Atian Grace, and I'm so delighted to take you through this specific lecture. I'm so excited to have you here. So I'm so happy and glad that you tuned in and are ready to listen to how we can prepare the invert syrup. Okay, so what are the requirements that we need? We have a number of requirements that we need when we are preparing our invert syrup. So we need a sucrose itself, we need it, and then hydrochloric acid, we also need it, and then we need distilled water. Okay, so these are the requirements. We are going to see how each requirement is going to act. You see that in this one, majorly active pharmaceutical ingredient is going to be sucrose, and then the rest are going to be like excipients that we need to add, and we are going to see what is their role and what exactly they are going to perform and what they are doing to the preparation, and then to why is it necessary to have it as a requirement. Okay, so let us have a brief theory here. We see that hydrolysis of sucrose, we just looked at a video or a lecture on a simple syrup, and then we saw that how we can prepare a simple syrup, and then here we are talking about invert a simple syrup or invert syrup. Okay, mostly we require this invert syrup when we it acting as a pharmaceutical aid. Okay, so we see that the hydrolysis of sucrose by boiling with mineral acid or by the enzyme invertase produces a mixture of equal molecules of D-glucose and D-fructose. Okay, sucrose solution is dextrorotatory, but after hydrolysis it becomes levorotatory. This should be rotatory, please, levorotatory. Okay, so we see that sucrose solution is dextrorotatory, but after hydrolysis we see that we are going to hydrolyze sucrose. When you hydrolyze sucrose, we form two components that we use to combine to form sucrose. Remember, sucrose is a combination of two sugars, sugars, and that is the glucose and fructose, and majorly the D-glucose and the D-fructose. When we combine them together, we form a sucrose. Okay, so when we hydrolyze sucrose, we form both of them. Like it is like we are splitting a big family to form smaller ones. Okay, and when we combine the smaller ones, we form the big one. Are we together? So the specific rotation of sucrose is always positive or plus 66.5 degrees. Dextrose or D-glucose, D-glucose has a specific rotation of positive 52 degrees plus 52 degrees. D-fructose has a specific rotation of negative 92, this is 92 please, 92 guys, 92 degrees. So the net specific rotation or ration is, we get the plus 52 minus the 92, which is our minus, divided by 2, we get minus 20. okay, we get our minus 20 degrees. And we continue in our theory. We see that in hydrolysis, the specific rotation changes from plus 66.5 degrees to minus 20 degrees. So a plus to a minus, it is like we are interchanging a plus to a minus. That's the word invert. Okay, hence the hydrolysis of sucrose to D-glucose and D-fructose is termed as inversion, and the hydrolysis mixture is called as invert sugar, invert syrup. Are we together? The relative sweetness of sucrose of sugars in sucrose is always 100. We see that in fructose is 173, in dextrose is 74, and then lactose we have 16. So lactose, sucrose, dextrose, fructose, those are all sugars. That's why we are putting it in plural sugars, not our sugar we use for tea. Okay, our sugar we use for tea, if I mentioned it sugars, it would really sound like there is no plural for sugar. Yeah, but with science we have different parts or categories or types of sugars, okay, and all of them have different sweetness, quantities of sweetness in them. That is why we see her seeing that sucrose has 100, fructose has 173, dextrose has 74, and then lactose is 16. Okay, so yeah, we have sugar in plural sugars. Okay, so that's all what you need to know, how the invert sugar thing comes about, how the invert syrup, why we are calling it invert syrup. Okay, so by now you know how we are going to prepare the invert syrup, where it is just the sucrose, the normal simple syrup, and we are going to add in some chemicals to enable hydrolysis to take place, and after hydrolysis takes place, behold, we get our invert syrup or invert sugar. Okay, so yeah, that brings us to the formula. What's our formula? Our formula, we need sucrose, and sucrose we need 66.7 grams. Purified water we need sufficient to produce 100 grams, and then we need hydrochloric acid is coming into neutralizer. I mean hydrolyze, please. QS is like a given quantity or a quantity that is able to hydrolyze completely our sucrose to D-glucose and D-fructose. Are we together? QS to a specific quantity. And then sodium bicarbonate solution, which is coming in as a neutralizing agent. Wow, here comes the procedure. Procedure of preparation. Let's dive into it. Prepare syrup of sucrose 66.7%. Weight in purified water. Remember we looked at a lecture on preparation of a simple syrup. Ideally, you use the same procedure for preparing the 66.7% volume in volume purified water. It is like that simple syrup that we prepared in the previous lecture. So if you have not looked at how we prepare that syrup, please tune in and see how it is prepared. So after you have made that simple syrup, after you have made your syrup or sucrose 66.7% weight in purified water, we are adding in hydrochloric acid slowly with continuous stirring. We are adding in hydrochloric acid to bring about hydrolysis of sucrose to D-fructose and D-glucose. Are we together? So after we have added it slowly while stirring, we neutralize the solution by adding in our sodium bicarbonate. Neutralizing the solution using our sodium bicarbonate, not bicarbonate, sodium carbonate, I'm sorry for that. use sodium carbonate solution, or for neutralizing because your acid might have been excess or gone excess. I don't know the right English to use. Yes, so you neutralize the solution. After you have done that, identify the inversion of simple syrup to invert syrup by measuring optical activity of the syrup. So after you have done the above, just try to check it out that have I made my invert syrup? And you can do it by measuring the optical activity of the syrup, or by taking 1 gram of the syrup and diluting it with 100 ml of distilled water, and after you have diluted it to 100 ml, add 5 ml of potassium capricitrate solution. You should see a red precipitate to confirm you have made your invert syrup. Okay, to confirm that you have made your invert syrup, a red precipitate should be formed or is formed. Note, what category is invert syrup? Anyway, we see that invert syrup is used as a pharmaceutical aid, or it helps us in preparation of other pharmaceutical preparations, other not excipients, other medicated pharmaceutical preparations. Okay, storage. How do we store the invert syrup? Invert syrup should be stored at 35 to 45 degrees centigrade because fructose is thermolabile and syrup darkens if not stored in a cool place. So these are like storage conditions that you put on your label. After you've packed your preparation, you put the storage conditions on your label. Remember, we have looked at a label in most of the lectures we have handled previously. Look at the different parts of the label in other lectures so that every preparation we look at, you write a label for it. Okay, so but this is like a storage condition you put in your label, the category you put in your label, and then the use. We see that it is used as a sweetening agent, can be used as a flavoring agent, and also used as a vehicle. Okay, so we have some questions. I have some questions here for you. If you came this far listening to this specific lecture, you should be in position to answer these questions. Where you get stuck, please put it in your comment section and we shall be here to help you. What is an inversion? What is invert sugar? How sucrose is converted to invert sugar? How is sucrose converted to invert sugar? Give pharmaceutical applications of invert syrup. How to identify formulation of an invert syrup? Identification tests for invert syrup. What is the difference between invert syrup and honey? How to control the reaction involved in inversion? Why syrup is stored? Why is this invert syrup stored below 45 degrees centigrade? Okay. In case you get stuck in any of the questions, you can also put your answers to these questions in the comment section so that I am able to know whether you understood and got the concept, so that in case you didn't get any concept at all, please put still in the comment section and we see how we can help you and how we can move together in the same pace. Thank you so much. Stay blessed and